Hello guys, welcome to Placeboard to Edu and my name is Vinay Kumar Nayan Bhathani. Today we are going to learn the analysis of resistors part 3. In this I am going to explain you why we have to learn open circuit and short circuit with simulations. So let's get started. If you see, this is open circuit and this is short circuit. Open circuit means you can see the terminals which are not connected, and short circuit means you will see a conductor directly. Okay, that's where the difference comes. And if you want to represent this as resistors, open circuit is defined or represented as R is equals to infinity, and the short circuit is represented as R is equals to 0. Okay, by taking R is equals to infinity we can represent open circuit, and by taking R equals to 0 we can represent short circuit. Now we will see how the voltages and currents are affected due to open circuit and how voltages and currents are affected due to short circuit. For that I am considering R is equals to infinity. Consider this circuit. This is something, let it be 5 ohms, and we have an open circuit here, right? I have already said you that R is equals to infinity for open circuit. Now we have to find R equivalent. It is clear that this 5 ohms and infinity are in series, so 5 plus infinity, it is not undefined but infinity. Since infinity is far greater than 5, R equivalent will be infinity. Understand? So now what will be the voltage? I have given already the voltage V. You can see it here. This V I am writing here. And now from Ohm's law, the current I is equals to V by R, right? Which is equals to V by infinity. V by infinity is equals to 0 amperes. So in open circuit, current will be equal to 0. So the I here will be equal to 0. So there will not be any current flowing through the open circuit, or there will not be any current in the circuit if there is an open circuit which is like this. Okay, now if I show you the simulation part of this open circuit, you will be understanding it somewhat better, right? You can see that current is passing, right? I will show the current here. See here, 1.3 milliamperes of current is flowing here. These are the values of resistors, and you can see the current flowing, and the voltage source is 5 volts. Okay, now what if I create a open circuit? If I create open circuit, the current flowing will be stopped. I am showing that. See here, now see, the current flowing is stopped. Even the simulation is running, you can see the yellow dots are stopped or freezed. See here, the time is running, which means the simulation is running, but the yellow dots are stopped, resulting in current is 0. But what is the voltage here? How can I know what is the voltage present here? For that I am keeping a voltmeter here. You can see here 5 volts. Understood? This is 5 volts and the whole voltage is across this open circuit. Understood? When the voltage source is 5 volts and if it is directly connected to the open source, so when the voltage source is something like 5 volts and it is directly connected to the open circuit, then whole voltage will be coming across 5 volts. Understood? This is very important conclusion what you have to take. So if open circuit has two terminals, that is plus and minus here, see here there are two terminals, one is connected to directly to the positive of voltage source and another is directly connected to the negative of the source. Therefore 5 volts is directly applying to the voltage source. Understand? Now coming to the short circuit. Short circuit means I've said you R is equals to 0, right? Now I'm writing here R is equals to 0. For example, I'm considering a resistor here, let it be 5 ohms, and this is 5 ohms. Unfortunately, some fault occurred and this resistor got short circuited, which means here R is equals to 0, right? So 5 ohms and R is equals to 0, that is 0 ohms are in parallel. So R equivalent will be 5 into 0 by 5 plus 0, right? R1 into R2 by R1 plus R2. Therefore, this is 0 ohms. So whenever a resistor or any component is short circuited, then the short circuited resistance will be dominant. So we have to redraw the circuit as this should be eliminated, and the circuit will be redrawn as 5 ohms and like this. So whatever the current is flowing through the 5 ohms will not flow now. This is short circuit. So I'm going to show you the simulation of this also. I have current flowing through this circuit. Okay, current is flowing through this circuit, that is 1.667 milliamperes, and the voltage source is 5 volts. Okay, now if I short circuited this series resistors, that is 1k 1k, if I short circuit it, what will happen? We'll see. See here, no current is flowing through this. I is equals to 0 amperes. You can see that the current is flowing through the short circuit. You can see here directly. I'm going to show you the current 5 milliamperes, because this is 5 and this is 1 kilo ohm. So the current which is flowing through the resistors will be shifted towards the short circuit, and you have to observe that the current which flowed before the short circuit will not be equal to the current flowing in the short circuit after short circuit. If you are confused, I am going to explain you here. For example, here consider a voltage of 10 volts here, and this is 2 ohms and this is 2 ohms. Okay, I think you are following it. So this will be 5 volts and this will be 5 volts. Okay, and what is the current flowing through here? What is the current flowing through both the resistors? It will be 10 by 4, since 2 are in series. So 2 2s, 2 5s and 2 2.5. So it is 2.5 amperes. But whenever I short circuited this 2 ohms resistor, this 2 ohms resistor is now not in use. Now the resistor will be only 2 ohms. Only 2 ohms is left behind the resistor. So the current now will be 10 by 2 5s. Okay, this is 2.5 amps. Now the current flowing through the short circuit is 5 amperes. Understand? That's what I said before. Okay, now why we are learning short circuit and open circuit? Short circuit and open circuit are useful for circuit analysis. Okay, whenever a short circuit is occurred in circuit, you can easily find that. And the other thing is, when we are doing analysis using switch, that is for designing of switches, short circuit and open circuit are used. I'll show you how. This is 10 volts, this is 1 kilo ohm, this is 1 kilo ohm. See, this is a switch. Okay, in order to design a switch, I have to find the voltage across the switch when it is open and the current through the switch when it is closed. There are so many specifications which we have to consider, but for a basic switch we have to consider voltage across it when it is open and the current across it when it is through it when it is closed. Okay, now the switch is open, right? the voltage across it will be the voltage across these two terminals, right? The voltage across these two terminals will be voltage across this 1k resistor, which is nothing but 5 volts. So here the voltage across the switch when it is opened is 5 volts, and the current through it when it is closed, the 5 volts or this 1k should be discarded. So it will be 10 by 1k. So the current will be 10 milliamperes, right? So when when switch is closed is 10 milliamperes. In this way, we can find the voltage rating and current rating, desired voltage and current rating of a switch. So if I show this in the simulation, see here, this is the circuit and I am running the simulation. If we see what is the voltage, it is 10 volts, right? So now 10 volts, the switch is open, right? So the voltage across the switch will be 5 volts. Since it is open, the current through it will be 0 amps, right? It is clear, right? When I close the switch, this 1 kilo ohm will be discarded and the current will be this much, 10 milliamperes, because this is 10 volts and this is 1k. From Ohm's law, V equals to I by R and I equals to V by R. So 10 by 1k. So now the voltage will be 0 volts and the current is 10 milliamperes. That's what I discussed here. Understood? In this way, we can use the open circuit and short circuit in circuit analysis.
Hope you guys enjoyed this video. So please like, share, comment and subscribe. If you guys didn't like this video, please let me know through comments. Thank you.